minus x, right? So again, it's like we're cutting the x out, put parentheses, right, on each one of these. So this will be f, let me go over here to the left more, f and then parentheses. And then where the x is we put parentheses, plus 2 over 3 minus, and where the x is we put parentheses again, right? And now we're going to put in, where x was, we're going to put in 1 over a. So we're going to put in 1 over a here and 1 over a here, right?
Dang it.
Okay?
I flipped it.
Oh, well, not yet. Not yet. You're going to, but not yet, because you have to do what in the numerator?
Find a common denominator.
Get a common denominator, right? Which is what for the numerator? A, right? So we got to multiply a over a here. And the denominator, same thing. A over a, right? So that's going to give us 1 over a minus 2a over a. So we can just make this all 1 minus 2a over a, right? All right, now for the denominator. What's that going to be?
3 minus
3 minus
3a. 3a minus 1.
Minus 1 over
a.
a, right. But we can't leave it that way, right?
Something's not right. Yeah, something's not
Oh,
right.
wait a minute, that's
Something's not right.
1. Okay, yeah, this should, okay, back up. Back up here. All right. We got 1 over a plus 2a over 1. Okay, so that's going to be 1 plus 2a
Over
all over a. And whether it was that or 2a plus 1, it really didn't matter, but that's okay. We'll leave it like that. Now here we're going to have, for the denominator, what are we going to have?
3a minus 1.
3a minus 1
over
all over
a.
a. Okay? But we can't leave it that way. We've got to simplify it, right?
Yeah.
So it goes back to that a over b
Yeah.
equals to a divided by b
Equals a times 1 over
equals to
b.
a times the reciprocal of b, right?
Yep.
So here we've got 1 plus 2a over a times
A over 3a.
a over 3a minus 1, right?
Dang it, that's where I messed up.
Yeah, well, where did you mess up? You
I
have to
multiplied it. I flipped it first, but I didn't flip it the second time.
yeah, see, you gotta get the common denominators first. You gotta simplify it first before you can flip it, because otherwise it won't work. Okay, now we can cancel out the common factors, right? And we end up with 1 plus 2a over, that almost looks like a 9, over 3a minus 1. Okay?
Alright, I get it now.
Alright, you were on the right track. You just had to remember to simplify before you went ahead and flipped it and multiplied. Okay. Next page. Any questions there?
Number 7E.
Number 7D?
E.
E? Okay, 7E.
You do F to it.
E and F, okay. 7E. Alright, for use interval notation to find the domain of each function. Okay, and we've got f of x is equal to square root of x squared plus 5x minus 6. Alright? Now, with this one, we know that when we have square root and we got x squared, we know that basically our domains are going to do what? One of two things. If we have A and B, right, and they're closed, okay, the graphs are going to do one of two things. What is it going to do?
Just in the middle or.
They're either going to be, all points are going to work in between, or
And then go separate ways.
they're going to go in opposite directions, right? So we need to find out, first of all, what is our A and B? Okay, and how do we do that?
Back to the bottom.
Factor, good. Take x squared plus 5x.
But you just take the square root off of it and then you can.
Yeah, don't even use the square root. Okay. Now normally for square root we use greater than or equal to, but for here, for factoring purposes, and we're going to use test points anyways, it's better just to set it equal to 0. Okay, and then what?
X
Plus 3 plus 2.
Careful.
X
Is our sign's going to be plus or minus?
X plus 6 X minus 1.
Plus and a minus, right? Because our C term is a minus. So it has to be plus 6 and a minus 1. Okay? That's why I always say to use the sign, put the signs in first. Because it's really easy with one like this to mess it up. Because it looks like, okay, we get 5, but you're subtracting, you're not adding. Okay, so we got x plus 6 equals 0, and x minus 1 equals 0. So we get x is going to be equal to negative 6, right? And x equals to positive 1. So here's our number line, right? Here's negative 6, and here's positive 1, right? And we know they're closed, right? Because it's a, because how do we know they're closed? Because they're in a radical, right? Okay, now we need to know, are they going in between? Are there points in between, or are the points opposite? So we do a test point, right? And 0 is always a nice one because it's easy. So if 0 works, then all points in between work. If 0 doesn't work, then none of the points in between negative 6 and 0 work and 1 work. And then that means that the points outside of negative 6 and 1 are going to be solutions. Okay, so just by looking at this, 0 and 0, is that going to be a positive or negative?
Negative.
You're going to get a negative radican, right? Because you're going to get 0 squared plus 5 times 0 minus 6, right? And you get a square root of a negative 6. Well, 0 is no good, right?
I can't see.
Oh. Is that better?
No, this thing's in the way.
Oh. So that means our points are what?
Outside.
Outside.
So is it like negative infinity, negative 6, and then negative 6 and 1, and then union 1 to infinity?
There you go. It'll be domain negative infinity to negative 6, and that's open or closed?
Closed.
Closed. Union. Then what?
Negative 6.
Careful, because we already determined that nothing works, right? Because we get a negative radican.
And then 1 to infinity.
1 to
Infinity.
infinity, right? It's not like with when you have x in the denominator